Good morning to all. Today's the topic is illumination. It is a chapter 4. We will discuss about the illumination. What is this actually illumination? Okay, so first the contents contain the introduction and terms of illuminations, and later different types of lamps are there here. Here we will study about different types of lamp like fluorescent lamp, mercury vapor, MV lamp, mercury vapor lamp, incandescent lamp, different types of lamp. Here we will study. Okay, and what are the terms related to your illumination, like solid angle and all these things, radiance, solid angle, luminous flux. What is this luminous flux? These so this is the overview of the chapters. So we will discuss one by one. So first we will discuss about the introduction, and we will discuss about the terms in illumination. What are the terms present? So introduction, what is the light? So everybody knows that what is this light? Light is a form of radiant energy. First of all, light we know that is a form of radiant energy. Okay, and lumen measures how much light. Lumen measures how much light you are getting from a bulb. More lumen means it is a brighter light. Few lumen means it is a dimmer light. So lumens are related to lux. So what is this lux actually? In the 1 lux is 1 lumen per square meter. This is the thing that. So we know the introduction means illumination. It is the basically about the illumination chapter. So light is the mandatory. So light is the one of the form of radiant energy. Lumen measures how much light you are getting from a bulb. More lumen means it is a brighter light. Less lumen means it is a dimmer light. We know all these things because this is the fundamental things. If it is more lumen, that means it is a brighter light. If it is a few lumens, means it is a dimmer light. So lumen are related to lux. So lux in that 1 lux is 1 lumen per square meter. Okay. So next terms is solid angle. So what is this solid angle? We will discuss again solid angle. First, this definition says that a 3-dimensional analogy of an angle such that subtended by a cone or formed by a planes meeting at a point, it is measured in a steradians. So basically angle units is radians, but solid angles its unit is steradian. This is an important thing that the solid angle unit is steradian. So now what is this radian? You know about this radian. This is the arc. So it is a radian. So let us consider here. See the arc length. See the arc length, and this is the radius. So 2 pi radians means it is, we know that 360 degrees. Pi radians means it is nothing. It is 180 degrees. So 1 radian is equal to 180 divided by pi degree, and 1 degree is nothing but your pi by 180 radians. So to convert from degree to radian, we will multiply pi by 180 degree. To convert from radian to degree, we will multiply 180 degree by pi. This is the thing. And here you can see that arc length is equal to your radius. That is the main motto. Arc length is the arc length, and this arc length is equal to your radius. So that means angle and solid angle we will discuss. Yeah, see here, angle, the ratio of subtended arc length on a circle to radius, that is denoted letter. See here, this is the theta is the angle. So this arc is L and the radius is R. So we know that circle has 2 pi radians because it is 360 degree. So it is a 2 pi radians. That is the angle. So what is the solid angle? We discussed before. The ratio of subtended area on the sphere. The ratio of subtended area on the sphere to radius square. Okay, that is called as a solid angle. So thing is that it is denoted letter ohm. So ohm is equal to your A by R square, area by radius square. So you can say that sphere has 4 pi steradians. So your sphere has you can say the 4 pi steradians, and your angle is 2 pi radians. Okay, so that is the difference between angle and your solid angle. That is clear. So if anybody will ask you what is the angle and what is the difference between solid angle, you can explain in this way. Here you can say the cone shape is there, and the ratio of subtended area on the sphere to the radius square, that is A. Here it is A by R square, you can say. Okay, and sphere has 4 pi, and sphere has 4 pi steradians. Clear? So now, what is this luminous intensity and what is this luminous flux? So what is this luminous intensity? So what is this luminous intensity? Luminous flux per unit solid angle, that is called as a luminous flux per unit solid angle, that is called as a luminous intensity. And the SI unit is candela, CNDL, candela, CD. You can denote it as the letter is CD. So it is denoted by a symbol I generally, and is measured in candela CD, and the lumen per steradian. It's you can say the unit is lumen per steradian, or it's called as a candela. So now come to the topic. I told that luminous intensity is the luminous flux per unit solid angle. We already discussed about the solid angle before. This is the solid angle. Yeah, this is the solid angle. And what is this luminous flux or luminous power? So luminous energy per unit time. So what is this luminous flux? Your luminous flux is nothing but your luminous energy per unit time. So luminous flux, generally it is in lumens, is measure the total amount of light a lamp puts out. That is called as your luminous flux. That is called as your luminous flux. Okay. And what is this lumen? So lumen means, what is this lumen? Lumen is nothing but candle power into solid angle. That is called as a lumen is candle power into solid angle. That is Cp into omega. You can say that lumen is denoted as a candle power into solid angle, or the total lumen gives out by a source of one candle is 4 pi lumen. It expresses the level of light intensity relative to the light emitted by a candle of a specific size and constituents. That is called as a lumen. So this is called a luminous flux. This is called total lamps out. So this is the thing, luminous flux. This is one of the graphical representations. So it's not required for you. So now we will discuss about the history. What is the history of the luminous flux? What is the history? So generally you know that luminous flux, oil lamp, it is 0.1 lumen per watt. Light bulb, it is 16 lumen per watt. Fluorescent lamp, it is 670 lumen per watt. And LED is 300 lumen per watt. So this is the thing of the solid angle. We discussed that A by R square, that is equal to ohm. Ohm is equal to A by R square. This is the solid angle. That is the pictorial representation. How the solid angle can be represented. So that means it is A by R square. Small a by R square is equal to your ohm. That is called a solid angle. So this is what is that candle power. So what is this actually candle power? The candle power was based on the light emitted from a candle. That means a candle power was based on the light emitted from a candle. That is called as candle power. That means how much the light can be emitted from a candle. You can say that there is the candle powers. and the pictorial representation of the candle power, you know that. So next come to the topic, what is this actually illuminations and the terms of illuminations, that we will discuss now. So what is this illuminations? Come to the topic, is illumination. It is defined as the number of lumens falling on the surface for unit area, that is called as illuminations. This is the important things, that illumination, it is defined as the number of lumen falling on the surface for unit area, that is called as illumination. It is denoted by a symbol I and is measured as a lumen per square meter or flux or meter flux or meter candle. If a flux of lumen falls on the surface area, then the illumination of the surface is lumen per meter. So basically illumination means it is defined as the number of lumen falling on the surface per unit. It is called illumination. There are two laws are there. One is the Lambert quotient law, another is inverse square law. That is two types of law are the law of illumination. We will discuss in next video lectures. So what is this terms related to illumination? That is called a MHCP. This is called a mean horizontal candle power. That is, what is the meaning of this mean horizontal candle power? It is defined as the mean of a candle power in all direction in horizontal plane containing the source of light. That is called the MHCP. That means it is defined as the mean of a candle power in all direction in horizontal plane containing the source of light, that is called the MHCP. What is MHCP? Mean spherical candle power. It is defined as the mean of candle power in all direction and in all planes from the source of light. That is called as a MHCP. So what's the reduction factor then? Reduction factor is nothing but your MHCP by MHCP. That is called as a reduction factor. And what is MHSCP? It is denoted the mean of a candle power in all direction above or below the horizontal plane passing through the source of light. It's the main important thing. The mean of a candle power in all direction above or below the horizontal plane passing through the source of light. That is called. What is this brightness? Brightness, it is defined as luminous intensity per unit projected area of either surface source of light or reflecting surface. That is the main difference. Or what is the solid angle? We already discussed that plane angle is subtended at a point in a plane by two covering straight line. That is called solid angle. We already discussed so many definitions regarding the solid angle. So what is the lamp efficiency? What is this lamp efficiency? It is defined as the ratio of luminous flux to power input. It is defined as the ratio of luminous flux to power input. It expressed in lumen per watt. That means basically we can also say that the ratio of luminous flux divided by power input, that is also called as a lamp. That is called as your lamp efficiency, and the unit of luminous flux is lumen, and what the unit of power is watt. So you can express as a lumen per watt. Clear? So what is the luminance and brightness? We can say luminance and brightness. Brightness means when the eye receives a great deal of light from an object, we say it is bright, and brightness is the important quantity in the illumination. So here we discuss about this topic, that is MHSCP and brightness, luminous, and your MHCP, that is the mean of candle power in all directions in horizontal containing the source of light. And MSCP, we discuss about the mean of candle power in all direction and in all plane source of light. Here another is MHSCP. It is defined as a mean of a candle power